part 4 of discrete random variables, the probability distribution. We're picking up with example 6, draw 4 cards. You're playing a game in which you draw 4 cards from a standard deck of 52 cards, and the cards are replaced in the deck after each draw. You guess the suit of each card before it's drawn. You pay $1 to play, and if you guess the correct suit each time, you win your money back plus $2.75. Will you make money playing this game in the long run? So to do that, we need to find the expected value. So let's figure out our random variables. So what are the possible outcomes? You could win the game, and if you win the game, you win $275. If you lose the game, you lose $1, so that's -1. Now to find the probabilities to win the game, you have to guess correctly all 4 cards. So if I'm guessing all 4, that means I want to guess that the first one's correct, then I want the second one to be correct, then I want the third to be correct, and I want the fourth to be correct. I'm going to multiply those together. So there's 1 suit out of 4 that would be correct for the first card. There's 1 suit out of 4 that would be correct for the second, and for the third, and for the fourth. So the probability of winning is 1/256. I'm going to leave it 1 out of 256 because I can let my calculator convert that to a decimal later for me. Okay, now what is the probability of losing? Losing means we are not winning, and the formula for that is find the probability that we are winning and subtract that from 1. So 1 minus 1/256. You can put that in your calculator, you can get a decimal, or you can just subtract it and leave it as a fraction, and you'll get 255 over 256. Alright, so you have 2 options. You can multiply these together and then add to get your expected outcome, or your expected value, or you can just use the calculator. So let me pull up the calculator, go back to that screen. There we go. Move this over so you can see it. So if you go to stat, enter. So you can win $2.75 or lose $1. Here what I did was I typed in 1 divided by 256 and it went ahead and converted it to a decimal for me. This would be 255 over 256. There you go. And then we'll, to get the expected value, we go stat, calc, var stats. My data is in L1 and in L2. And we get 0.078125, 0.078125. Okay, so the expected value is really about 8 cents. 0.078 would be about 8 cents. So it does look like it's a gain, not a loss, but 8 cents is not very good. So on average, if you repeated this a bunch of times over and over and over again, then your average outcome would be about 8 cents. So, all right, so here we have a biased coin game, or a game where you flip a coin, but the coin's biased. So that means that it's not it doesn't have a probability of 1/2 of getting a heads. The probability of getting heads, because the coin's going to be weighted, is 2/3, and the probability of tails is 1/3. So you toss the coin once, and if your toss is heads, you pay $6. If your toss is tails, you win $10. If you play this game many times, you come out ahead. So why don't you pause the game, or I can't even speak today. I'm sorry, you guys. Pause the video. This is not a game. Pause the video and then come back after you've worked the problem and see if you've got it correct. Okay, so here we go with the answer. You can lose $6 or you can win $10. The probability of losing 6 is the same as tossing a heads, because you lose if your toss is heads, and the probability of a heads is 2/3, as it said right here. If you win $10, that's the probability of flipping tails. The probability of flipping tails is 1/3. If I multiply across, if I'm doing this by hand, okay, -6 times 2/3 is -12/3. 10 times 1/3 is 10/3. If I add that together, I get -2/3, which is -0.6667. So it is a loss. If I do this with the calculator, you do L1, this is L2. Stat calc var stats L1 L2, and you will get the same thing for X bar, which is your expected value of -0.6667. Okay, so here I have 3 examples. 1, 2, 3. So why don't you attempt these and then pause the video to do that. And then come back and we will go over all of the answers. Okay, here's the answers. For the first one, the expected value is a loss of $12.75. So the way we got that was the box had 10 $1 bills, 5 $2 bills, 3 $5 bills, 1 $10 bill, and 1 $100 bill. So 20 bills total. The person is charged $20 to play, to select one bill. And I guess they get to keep the bill that they pull out. So if they pay to play $1 and they pull out, I'm sorry, they don't pay $1, they pay $20. If they pay $20 to play and they only pull out $1, they've lost 19. If they win $2, they've lost 18 because they have to pay 20 to play. If they win $5, they've still lost 15 because again they've paid $20 to play. If they win $10, they've lost $10 because they have paid 20 to play. If they win 100, they've only won 80 because they paid 20 to play. Now the probability of each was there's 10 $1 bills, so that's 10 out of 20, 5 out of 20, 3 out of 20, 1 out of 20, and 1 out of 20. If we find the expected value, we get $12.75. For the second one, if a person rolls doubles when tossing 2 dice, they win $5. The cost to play the game is $1. What is the expected value? So if they win 5, but they pay $1 to play, they only win 4. If they lose, they've lost $1. Now to find these probabilities down here, what I did was I looked at the sample space from example 1, and I counted all the ways you could get doubles. Here's 1, 2, 3, 4, 5, 6 ways to get doubles out of 36 total in the sample space. And then that means there's 30 ways to not get doubles out of 36, so 30 ways to lose. And for that probability, I got -0.1667. I'm sorry, for that expected value, which is -17 cents. So again, a loss. Then we have a raffle that sells 100 tickets. This is key here, 100 tickets at $5 a piece. You can win 500, 100, or $50. What's the expected value? So here are the outcomes. You could win 500. But pay 5, which gives you a profit of $4.95. You can win 100, but pay 5, profit of $95. You can win 50, but pay 5, again, profit of $45. Or you could lose because there's 100 tickets. So some of these tickets aren't winners, and if you lose $5. So I counted up. There's one $500 prize, 5 $100 prizes, 10 $50 prizes. That's a total of 16. That doesn't account for the remaining 100 tickets. So 16 plus 84 is 100 tickets, so that means there's 84 losing tickets. So the probability of a profit of $4.95 is 1 out of 100. 95 would be 5 out of 100. 45 would be 10 out of 100, and losing would be 84 out of 100. The expected value when we calculate this is $10. All right, so that is all of the probability distribution and expected value. If you have questions, as always, please ask.